Water in a wave stays pretty much in place and only the wave shape moves forward? Let's find out how the water in a wave does move. We'll use a wave tank again, but instead of using wind to make waves, we'll use a mechanical wave generator. The regular movement of the wave generator makes waves that are very much alike. These relatively simple waves are easier to study than the complex waves we find in the ocean. A small ball floating near the surface of the water behaves in much the same way as the larger ball did in the ocean. Let's watch it in slow motion. Each time the high point of a wave called the crest approaches the ball rises and moves forward with the wave. As the crest passes and the low point in a wave called the trough approaches the ball moves down and backward. After each cycle, the ball is back to just about where it started. The motion of the ball is almost circular. This means that the water on which the ball is floating is moving in a similar orbit. We can imagine that the ball represents a particle of water near the surface. By putting weighted balls into the water, we can see what happens under the surface. The uppermost ball moves in an almost circular orbit. But the deeper we go, the smaller the orbits become and the slower the water particles move. Finally, at a certain depth, there is no orbit at all. If we measure the depth at which a wave no longer moves the water particles, we find that this depth is equal to about 1/2 the distance between two successive wave crests. This distance is called a wavelength. The deepest ball is at a depth greater than half a wavelength. The upper balls are less than half a wavelength deep. Now we know something about how water moves in a wave.